That's crazy. All right, awesome. All right, so let's look at section 6A, graphing radical functions. Graphing radical functions. And we've already done a little bit of this in the square root graph. So let's start with the square root graph, and then we'll see where we're going to go from there. So our square root graph, y equals square root x. It's hanging off the television over there. You can see it there, right to the, am I pointing? No, point that way. There it is. It's right over there, right? Oh, can you see it? Yes. Hopefully it's still there later on when someone watches this. Let's see here. I guess if you're on YouTube, you're not going to see it, are you? So let's get our graph here. And the square root of 0 is 0, and the square root of 1 is 1. So let's include those points. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And that's as far as we'll need to put points. There we go. So that's a square root graph. We don't take square roots of negative numbers, especially when we're graphing, because we're not, this is all the x and y coordinates here are real numbers. We don't have any complex, no i's. So that's just what we'll have. The y equals the square root of x. Let's also note the domain and range while we're here. The domain x starts at 0 and goes up. So the domain is x is greater than or equal to 0. And the range starts at 0 and goes up. So the range y is greater than or equal to 0. We're going to step this up. Basically, any even root would look like this. So we'll just do the second one. If we have the fourth or some other even root, it would look basically like that. But we need to look at the odd ones as well. So let's look at y equals the cube root of x. And when we take a cube root, we can do negative numbers. That's okay. So this is there's going to be a little bit more to this graph. There's going to be a positive and a negative end. So it'll be symmetrical. So the cube root of 0 is 0. Let's start with that. And the cube root of 1 is 1. We'll have that as well. And the cube root, what's our next number? The cube root of 8. So I need to go all the way over to 8. 1, 2, 3, 4, 5, 6, 7, 8 is 2. The cube root of 8 is 2. So all the way over there. And this is terrible how I drew this. You can see my x-axis lines get closer together because I was running out of room. And that's awful. They should be spaced out evenly. So shame on me. And I'll just have to try harder later. Okay. Now, this also works with negatives. So the cube root of negative 1 is negative 1. So it's going to be symmetrical, kind of like a copy. And the cube root of negative 8, oh, I'm going to do the same thing because I'm going to run out of room. Sorry about that. Is negative 2. So the graph is going to kind of look like, there we go. Okay, so there's y equals the cube root of 8. Slightly annoying because I have to draw all these lines to get out to that 8, but other than being slightly annoying, it's okay. I'm going to label these points over here as well. So the cube root of 8 is 2. The cube root of 1 is 1. The cube root of 0 is 0. The cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. All right, I just feel better. I want to actually label those numbers, see where we're at. Okay, to graph any cube or square root or whatever, let's see. Y equals a, and then the square root or cube root, and I'm going to say any number here, any number, a little pound sign means number, any number, x minus h plus k. This is our general form. Remember, the x kind of does the opposite of what you add or subtract there. If you're adding there, it moves left, subtracting moves right. So that's why we put a minus sign here. Okay, so to graph any function that looks like this, we have 3 steps. Step 1, identify parent function. Identify parent function. And that basically just means, is it going to be like this square root or like this? Does it have a cube root? So that's all you're going to look for there. So that first step is pretty straightforward. Number 2, multiply y coordinates by a. Multiply y coordinates by a. And that is if there is a value of a. Okay, if there's no number there, it's like 1, and multiplying by 1 doesn't change anything. So I guess if there is a value out there for a, multiply the y coordinates by a. So multiply the y coordinates by a. Okay, and your final step is to do the up, down, left, right stuff. So if this is a complicated graph that you're doing, you might have 2 or 3 graphs that you'll make along the way to get to that final function. So maybe showing your work will involve showing those intermediate graphs. By the way, there's one other thing I want to note here, and then I'll stop for a little while. If you have an x coefficient, factor it out. So you'll notice that I didn't leave an option to have anything in front of the x. If you do, we're going to factor it out. We can get rid of it. So let's see. If you have an x coefficient, let me switch colors. Boring with this green. If you have an x coefficient, if you have an x coefficient, factor it out. Whoop, FAC, I made my C into my T. So let me give you a quick example of how to do that. Let's say we have the square root of 4x plus 8. Well, I don't want any coefficient in front of my x, so let's factor it. Okay, and this went into, the 4 went into that. So that was pretty straightforward. If it didn't go evenly, we'd have to force it somehow to go evenly, but the ones in our lesson today will go evenly. And then the square root of 4 is 2. So this is 2, square root of x plus 2. So if you have a coefficient in front of the x, factor it out like this and then finish the rest of the problem. And that's it for your notes. Go ahead and do your left-hand side.